In electrical systems, particularly three-phase systems operating at 277 volts or 480 volts, adhering to a standardized color code for phase identification is paramount. This color coding ensures safety, facilitates maintenance, and prevents potentially dangerous errors during installation and troubleshooting. Let's delve into the specific color assignments for each phase in both 277 volts and 480 volts systems. For a 277 volts three-phase system, the designated colors are as follows. Phase is identified by the color brown. Phase B is identified by the color orange. Phase C is identified by the color yellow. It is important to note that these color assignments are not arbitrary. They are defined by electrical standards and codes such as the National Electrical Code, or NEC. Using these standard colors allows electricians and technicians to quickly and easily identify the different phases of the electrical system. This is essential for tasks like connecting equipment, troubleshooting problems, and performing maintenance. Now, let's shift our attention to 480 volts three-phase systems. The color assignments for this voltage level differ slightly from those used in 277 volt systems. Phase is identified by the color brown, similar to the 277 volt system. Phase B is identified by the color red. Phase C is identified by the color black. The differentiation in color codes between 277 volts and 480 volt systems is intentional. It prevents confusion and ensures that personnel working on the system can readily distinguish between the two voltage levels. This distinction is extremely crucial for safety, as working on a 480 volt system can pose a greater risk of electrical shock than working on a 277 volt system. It is important to emphasize that consistent application of these color codes is not just a suggestion, but a requirement in many jurisdictions. Electrical inspectors often verify that phase conductors are properly labeled with the correct colors during installations. Failure to comply with these color coding requirements can result in failed inspections and costly rework. The proper application of color coding is also important when working with motor control centers, or MCCs, and other industrial control panels. Inside these panels, conductors are often densely packed, and it can be difficult to trace wires without proper color identification. By using the correct color tape or marking methods, technicians can easily identify the phase conductors and perform maintenance or troubleshooting tasks efficiently and safely. Moreover, the color coding system extends beyond simply identifying individual phase conductors. It is also used to identify the grounded conductor, often referred to as the neutral conductor, and the equipment grounding conductor. The grounded conductor is typically identified by the color white or gray, while the equipment grounding conductor is identified by the color green or green with a yellow stripe. These color assignments are critical for ensuring that the electrical system is properly grounded, which is essential for preventing electrical shock hazards and ensuring the proper operation of overcurrent protection devices like circuit breakers and fuses. Now let's talk about some practical considerations when applying color codes in the field. The most common method for marking phase conductors is to use color-coded electrical tape. This tape is readily available in a variety of colors and widths and is easy to apply. Simply wrap the tape around the conductor near the termination point, such as a breaker, contactor, or terminal block. It is important to ensure that the tape is wrapped tightly and securely to prevent it from unraveling over time. An alternative method for marking phase conductors is to use color-coded heat shrink tubing. Heat shrink tubing offers a more durable and professional-looking solution compared to electrical tape. The tubing is slipped over the conductor and then heated with a heat gun, causing it to shrink tightly around the conductor. This creates a permanent and secure color-coded marker. Another method is to use permanent markers specifically designed for electrical applications. These markers are available in a variety of colors and can be used to write directly on the insulation of the conductor. However, it is crucial to use markers that are specifically formulated for electrical applications, as regular markers may fade or bleed over time. It is also important to consider the environment in which the electrical system will be operating. In harsh environments, such as those with high temperatures, humidity, or exposure to chemicals, it may be necessary to use more durable marking methods such as heat shrink tubing or engraved labels. Regardless of the marking method used, it is essential to ensure that the color code is clearly visible and easily identifiable. This is particularly important in dimly lit or confined spaces. Regular inspections should be conducted to verify that the color codes are still intact and legible. If the color codes have faded or become damaged, they should be replaced immediately. In addition to adhering to the standard color codes for phase identification, it is also crucial to follow all other applicable electrical safety practices. This includes wearing appropriate personal protective equipment such as safety glasses and gloves, and energizing equipment before working on it. It is also important to be aware of the potential hazards associated with working on electrical systems, such as arc flash and electrical shock. Proper training and experience are essential for working safely on electrical systems. If you are not qualified to work on electrical equipment, it is best to leave the task to a trained professional. Maintaining accurate documentation of the electrical system is also crucial. This includes creating and updating electrical schematics, panel schedules, and other relevant documents. These documents should clearly indicate the phase color codes used throughout the system. This documentation can be invaluable for troubleshooting problems and performing maintenance tasks. Now, let's consider some common situations where proper phase identification is particularly important. One such situation is when connecting a three-phase motor to power supply. If the phases are not connected in the correct sequence, the motor may rotate in the wrong direction. This can damage the motor or the equipment it is driving. By properly identifying the phase conductors and connecting them in the correct sequence, you can ensure that the motor rotates in the correct direction. Another situation where proper phase identification is critical is when paralleling transformers. Paralleling transformers involves connecting two or more transformers together to increase the overall capacity of the system. However, if the transformers are not properly phased, they can create a circulating current that can damage the transformers or the connected equipment. By carefully verifying the phase relationships and connecting the transformers in the correct configuration, you can avoid this problem. Proper phase identification is also important when working with variable frequency drives, or VFDs. VFD are used to control the speed of electric motors. They are often used in industrial applications to improve efficiency and reduce energy consumption. However, VFD are sensitive to phase imbalances. If the input phases are not balanced, it can damage the VFD or cause it to malfunction. By ensuring that the input phases are properly balanced and correctly identified, you can prevent these problems. In summary, adhering to the standard color codes for phase identification in 277 volts and 480 volts three-phase systems is essential for safety, efficiency, and reliability. By using the correct colors, electrical personnel can quickly and easily identify the different phases of the electrical system, preventing potentially dangerous errors and ensuring the proper operation of equipment. Remember that for 277 volt systems, phase is brown, phase B is orange, and phase C is yellow. For 480 volt systems, phase is brown, phase B is red, and phase C is black. Always double-check your work and verify that the color codes are clearly visible and easily identifiable. Following these best practices will help ensure the safety and reliability of your electrical systems.